Welcome to Walkabout the Galaxy, the evolving astronomy podcast where the science is universal, the opinions are personal. And is this 2015 again? We are Strange, Charm, and OG Top, the Astroquarks, also known as Josh Caldwell,
Addie Dove
And Tracy Becker.
coming to you
with the
from
Jim Cootie wag.
yeah, coming to you from distributed locations around the internet. Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked, but you can count on ours. So like and share and tell your friends about the astronomy podcast for people who don't really care that much about astronomy and for people who think astronomy is really cool. Catch our videos on YouTube. We're at Walkabout the Galaxy. You can email us at wtg@ucf.edu. So welcome back, Tracy, the original top quark.
Thanks for having me back.
Yeah. Um, Good to have you here at Southwest Research Institute in San Antonio. So we'll have hear about some of the stuff that you've been up to recently and some of your projects. Um, Tracy, remember we start with a stumper now because back in your original days we weren't doing stumpers,
We
but
didn't
you've
do a
been
lot
on
of
a few
things back then.
times. You've been on a few times since then, and
It's
so
true.
you're familiar. You're ready for a stumper.
I'm ready.
Ready for a stumper. Um, as you know, I've just reached the end of what I'm calling my rolling quartz year. Has just ended.
It wasn't even a year
So
though.
I kind of started last July, so it's almost been a year. That's like when I first started
Okay.
following the band until the culmination with being a groupie. Um, and I
I
kind of
see.
think it would make a great movie, like that.
Yeah.
What was the movie about the old women and Tom Brady that was based on a true story?
T. Brady.
Yeah,
Whatever.
I kind of feel this is like at that level of oddity and therefore potentially as entertaining, elderly astrophysicist and the
Now we
niche
have to think about who the
Korean
quirky
rock
people are
band.
that play you, and
Oh yeah, right. Again,
quirky people are who
well,
play you, and all the different people you meet. So it'll be
right.
fun.
Yeah. Okay. So we'll have casting call out shortly. Our stumper today is imagine that you're going to have a cosmic musical performance somewhere. Who would you like to
Ooh.
see and on what planet, real or fictional planet? So you can go to Star Trek, Star Wars, Guardians, MCU, pick your fictional, or if you just want to go to Mars or Europa or wherever the case may be, who would you like to see give a cosmic concert and where?
Yeah. Oh, I know Tracy's answer
Oh, you do?
for
You
the
know half of
band.
my answer.
I know half. I know the band or
Mm-hmm.
the group. I don't
Mm-hmm.
I,
know. I don't
is
know
it
which
is it the
location
same
it's
one
in.
that it would have been 20 years ago, Tracy?
Yep. Indeed it would.
Okay. Okay.
You go first.
I go
Go
first.
ahead then and put us out of our suspense.
Okay, so my favorite group is a group called Bone Thugs and Harmony. You may
Natch.
remember them from their hit single in 1996 called The Crossroads.
Oh yeah.
But actually, recently there was, oh no, there's a show with a comedian, and he did a whole skit about trying to get Bone Thugs on a show and like talk to who he thought was their manager, but might have just been a guy like shaking him down for money. So they're kind of still relevant. So he was almost on that
Oh, it was like
show.
John Mulaney,
John
wasn't it?
Mulaney, yeah, that's right. And so that's entertaining. But I
Yeah.
think where would I see them?
Are
Well, it
they
would
first? Let me ask before you say that.
sure.
Are they
Yeah,
still active?
yeah. Yeah,
Okay. And
one
so
of the
would you
They're
see?
members
still
one of
buzzing
the
and
members goes in and
harmonizing.
out. Sometimes he doesn't show, sometimes he's there, but
Okay, but I'm going to give you the option just to make this more challenging and interesting for you. Which era of Bone Thugs and Harmony you want? So you can time travel. You can have
Oh,
1996 or you can
jeez.
have 2016 or 2025 Bone Thugs.
yeah, pre 2004.
Okay, pre
Yeah.
2004 Bone
hmm
Thugs and Harmony, and where are
Yeah,
you
like
going to
East
watch them?
1999 era, that
Yeah.
album era. And I was thinking it would be cool to go, like, if I got to just transport myself to Europa, since that's, my favorite
You,
place right now. But there's no atmosphere there, so I don't think the music would carry very well.
you
So,
can you can you're going to have you can construct an arena. You're going to have glass walls so you can see Jupiter in the backdrop.
oh, that would be pretty cool. Um,
Yeah.
yeah, I mean they're from Cleveland, so cold. That still works. We'll go
Yeah.
Europa.
Europa. Okay.
Boring.
Yeah. Addie, who do you want to
I
hear?
like don't have an answer to this one. I'm so stumped that I like don't have a good answer. I don't
Yeah.
Fun.
know.
You would see fun.
Well, I would see the Format, which predated Fun. So
Mm.
my all-time favorite band is called The Format, and it was a band that existed before the band became the lead singer joined made a band called Fun, which had it did have some like hits, like Some Nights, and there was another one. Um, and they did very small venues. I saw them, Josh. I don't know if you remember this. There was a little tiny venue in the Union at CU that was like near the bowling alley, and
Oh
there was
yeah.
like this little tiny room that was a little music venue, and I think it fit like 50 people. And I saw the Format play there one time. Anyway, amazing.
Was that the greatest thing ever?
Um, no, but it was pretty awesome.
Yeah. So you would see them in a small
But
venue
I
on the
think I would
moon.
see, but see, I don't think I would see them. I think I would want to see some band that does like a really awesome, like theatrical
Big light
show.
show.
Yeah, like big light shows or like, or dynamic things that they do up on stage, right? So I'm thinking like of some of like the rock bands from, I don't know, somebody uh, like Freddie Mercury or somebody, right? Would be amazing
Okay.
to see like in a really cool, at a lower gravity environment.
Uh,
Somebody who like does really cool stage performance. I don't know, something like
Are you
that.
familiar with Protozoa?
No.
let's see
No.
how many completely unheard of bands we can mention on this show because
So,
we're doing pretty well so far.
well, Protozoa is also a fictional rock star who plays the music on Xenon Girl of the 21st Century on the space station.
There you go.
So it's also very
There you
relevant
go.
for anyone watching Disney movies circa late 1990s.
Okay, I'm sure we got a lot of people doing that right
Yeah.
now.
Oh,
Yeah.
yeah.
If I disqualify Rolling Quartz from
Yeah.
my list, then I would go with, I think I would, for the hell of it, I would have an orchestra doing the soundtrack from uh, like Star Trek the Motion Picture. And I would be on a moon of Saturn and have that kind of
Can I one up
celestial
you?
thing going. Sure.
Can I say I would love like an orchestra to be performing the planets, but do each one on the respective
Oh,
planet?
sure.
There you go.
All right.
Okay,
Well,
great.
today we will talk about the sun's corona, speaking of planets, planet
Ooh.
formation, and much more. But first, this episode of Walkabout the Galaxy is brought to you by lava fountains. For your next big wedding or other celebration, forget chocolate
Mm.
fountains because nothing pairs better with ice sculptures than lava fountains. Available in sizes up to 3 kilometers in height, lava fountains will dazzle your guests with their fiery displays of molten rock, providing a warm counterpoint to the cool night air. Choose from a wide variety of models, including steady stream and pulsating fountains, and time them to your DJ's soundtrack. Not responsible for incidental conflagration, lava fountains are for outdoor use only. Use only with appropriate adult supervision. Lava fountains. Life is a ball.
Life is a ball.
Life is a ball.
Sounds
Lava
hot.
Um,
fountains.
Life is a ball, and it's lava fountains. I'm like totally blanking right now.
Yeah.
Oh, we're
Um,
supposed to guess who the sponsor is.
Yes.
well, no, who the tagline comes
Who
from.
Mm.
who Life is a ball is
Uh, yeah.
is blanking. You have to
Um,
say
I'm
something.
like totally blanking. I'm totally. Ah, uh,
This
uh,
is good stuff though. Tracy,
I don't.
you're also helping out. You're doing
I
great too, Tracy.
I
Welcome
wasn't.
back to the show.
Thanks, thanks. Yeah. Uh,
I'm loving it.
glad I could
You
contribute.
bring in some good
Dead
energy.
I
air.
bring a lot of great energy, a lot of good facial
Yeah.
Um,
expressions for the podcast.
let's. Who
Okay, you
makes?
both lose. So chocolate fountains was mentioned in the thing. So you want to
Yeah.
guess again with that as a clue?
Toblerone.
Oh,
Okay.
what's it with the F? Ferrero chocolate.
Rocher.
Ferrero
Oh, that's
Rocher.
good. Tracy's Becker. Tracy's Becker. Tracy's
Tracy's
closer.
Becker.
Tracy's Becker and closer. It's Lindt
Uh,
chocolate. So
It's
they also have the
Addie
spherical
and
chocolate
I,
That's
treats.
it. I was
Addie and I
trying to
went to
think of
the
what that
Lindt.
company was named, and I couldn't think
Mm,
of it.
we
So
went to the Lindt factory once in
Yeah.
Sweden.
yeah,
It was delicious.
in
Cool.
Switzerland. Switzerland?
Oh, Switzerland. You're right.
I
Sorry.
would, yeah, I would have been surprised. Uh, I've got a hot take. I don't know how hot a take this will be. It's maybe just a dated, nerdy take, but it ties into our show a little bit. So, um, when I was a kid, I was a Trekkie. Then
No
people
way.
started saying, "Oh no, it's not Trekkie. We're Trekkers." And my hot take is no. Star
No.
Trek fans are Trekkies. They're not
Yeah.
Trekkers. They're not going on Trek.
No.
They're Star Trek fans. They're Trekkies. And Walkabout fans are Walkies because walkers are
Those,
zombies.
yeah, those
And
are zombies from The
walkabout
Walking Dead.
and walkabout fans
Are
who
not
write
zombies.
us a review or send us a note are walkie talkies. Hot take.
Oh, no.
So
You had
be
me.
a
I was
walkie
like
be
waiting
a
for
walkie
something
talkie.
along those lines, and then you lost me.
What? How could I lose you? That was like such a clear, straight line with no breaks
I
or
wasn't
bends or anything
confused.
like
I
that.
just don't like walkie-talkie.
It's not on board. Jumped
Oh,
Yeah,
well,
off.
I'm just
it's
not
a
on
hot
board with
take.
it.
Hot take.
I know it's not really a hot take, but it. I think the
It
hot
is.
take
It
of
is because you're not on board. If you were on
I
board,
think
it wouldn't be a
A
hot
the
take.
bit
temperate
in there that
temperate
was a
take.
hot take. That's just, well, I think it's just an idea, but the bit in there that was a hot take was like the Trekkie versus
Trekkies.
Trekker thing. I think
Trekkies.
that's good.
That's the
Yeah,
hot take. And then I'm just using that.
that's the
So
hot take.
anyway,
Yeah,
be a walkie-talkie. Write us a nice review or send us a note. Tell us how
that's
much
right.
you enjoyed hearing about bands you've never heard of
Do you
and
remember?
TV shows you never watched.
Do you remember when we first got our watches and we did the walkie-talkie thing to each other once or twice? That
I
was funny.
know. That was like a cool thing for like 3 days.
It was very
Yeah.
strange.
Space news.
Yeah.
Starship did have
Space
its
news.
ninth.
Another rocket blew up.
Yeah. So,
Go
what
ahead. You
happened
said
this
it
time
more
around?
eloquently.
I don't think so.
Um. Oh. Sorry, my internet is not loving the storm or something that's happening right now.
Integrated
Um,
Flight Test 9, ninth test of
ninth,
the Super Heavy with Starship,
yes.
and they both blew
Yeah,
up.
and they reused the super heavy booster on this one. So that was interesting, right? They reused the first stage, the booster, and it did not, it will not be reused again. So they
No,
were
but
like
it did
trying some
handle
sort of,
it handled the going up part okay. It was the
it
coming
did. It
down
went
part
up,
that it didn't do well.
it went up, it separated. That part all looked great. And then after it separated, they were apparently trying to do some weird re-entry angle or something with it. Like it was supposed to flip and then do something else. But anyway, whatever it did, it then blew up. Um, and then the starship part, the ship part, seemed to be going okay for a while. And it was coasting, and it was a suborbital flight, so it doesn't actually get orbital. But then apparently it did not go okay, and it
So it
went
made
floaty again.
it made it a little bit further than the last two starships, which
It
blew up
did,
while they were still
which
climbing
is
into
good.
space. And this one made it up into space, and it was coasting over towards the Indian
My hot
Ocean.
take
Yeah,
My hot take is like this was not a good. They're not making progress right now. This is not good sequential things. Like they're not really. I don't know. Like they're not big incremental things. And like the thing that didn't work this time was like there were supposed to be payload bay doors that open, right, to deploy some Starlink simulators or whatever. And
yeah,
like that didn't even work. Like that has nothing to do with testing their engines or all this stuff. That just like didn't work.
right.
And as you were watching the video, were you like freaking out about all the FOD that was flying around in that thing? I was like,
Oh,
why is there so much debris just like flying around everywhere inside of the ship? But
yeah.
I guess it's the thing they know is probably going to burn up anyway, so they're not super worried about it. But
Well, but
maybe
yeah,
one of
it's
those
true.
screws was important.
They have had 3 tests in a row to validate the sort of new version of Starship, and
Yeah,
all 3 of them have failed. Not
yeah.
exactly in the same way each time,
No,
but
but
you
it seems
know,
like they're not really fixing all of the issues that they're having each time. So I don't know.
right. Yeah, yeah.
I'm not
They do
fangirling anymore.
have this, so the FAA will have to investigate the Starship explosion.
Sure.
They don't have to investigate the other one because apparently they already
The
said
booster.
the booster may, have these various problems, and so it's kind of like already covered by
Yeah,
that and wasn't posing any sort of
yeah.
public safety threat. But they also I don't know, they're cranking these things out at a pretty rapid pace and are promising flights, pretty rapid sequence, but they'll have to demonstrate to the FAA that they're not going to have like random things crashing down on the planet at random places.
Yeah, and after
Yeah.
the flight, Elon Musk did some press conference thing about his plans to colonize Mars and said they were going to launch to Mars by 2026.
Well,
I don't volunteer for that flight.
Oh,
yeah,
oh
I'm
no.
betting that will be a robotic mission without any
Also,
people on board,
in
I'm
recent
guessing.
clips, and I think in that thing, he never
Yeah.
referenced Artemis in that speech, but in other clips, of stuff I've seen online, he's been asked about like Artemis and blah blah
I'm going
blah.
to have to do
He's
some
like, well,
editing here since I've
we
lost
just need
both of
bigger
you.
goals. We don't just want to do what we did during Apollo and put boots and blah blah blah. And I'm like, that's not. He's like, we need to make a moon base. I'm like, that's what Artemis is. So
Right.
anyway,
Yeah.
it was a rough week.
Tracy, your what's your official title on the Europa Clipper mission?
I am a co-deputy PI for the Europa Ultraviolet Spectrograph instrument, Europa UVS.
Okay. And
Nice.
as a reminder to our listeners, Europa Clipper launched when and where is it and what's it going to do?
It launched in October of 2024, and that was after a hurricane went right on top of the launch pad on the day that it was supposed to launch, which was October 10th.
Yay.
It was supposed to launch, and the eye of the storm was about 2 miles south of the launch pad that it would have been on at
Wow.
that moment, at that exact moment of takeoff. And so it was delayed until the 14th, and
Yeah,
then
that
it
was also
launched.
exciting.
Yeah, it was exciting. It was my only hurricane in the 6 years I lived in Florida. I never saw a hurricane, but I got to come back and experience one.
Cool.
What was the
I
second part
know.
of the
I love
question?
that for you.
What is it?
Oh, that's a good question. So Europa Clipper is a mission designed for searching for evidence of habitability of Europa. So it's not meant to necessarily be a life-finding mission, but it's
It's
supposed to
going to be looking for
understand
like huts, ruins, things like that,
some monoliths and
roads, ancient
things.
roads, pyramids.
Yeah,
Hmm.
mostly
Aqueducts.
mostly those things. But yeah, mostly looking for things like the temperature of the subsurface ocean on the moon Europa, which is the moon of Jupiter. Trying to understand what the salinity level is. Is it comparable to that of Earth's that we understand life could maybe be in, or is it so salty that it sounds absurd that microbial life could be there? So yeah, trying to understand the
I'm pretty salty about it.
So,
geology, see if some of the water is coming up to the surface, or water volcanoes, even better than lava volcanoes, may be erupting there. So we might be able to fly through one and sample the subsurface ocean directly.
how deep is Europa's ocean? How far beneath the ice? How thick is the ice layer on top of the ocean?
That's one
A
of the
great
questions we're going to
question.
find out. So we have we do think
Okay,
like
give me
on the order of a couple of kilometers. Uh,
only.
yeah, and
That's pretty
so
thin.
yeah, it's like tens of kilometers, and so
Okay, well, that's
couple
different
couple
than a
to tens,
couple.
couple to tens. Um, but we have two radar, well, one radar instrument with two different radar frequencies that will basically penetrate through the ice and potentially hit the top of the ocean if it's high enough.
Okay, and so you'll be able to place at least some sort of lower limit on the thickness of that ice layer if you don't get all the way through it to the water. And is that how you mentioned determining the temperature of the ocean? Um, and how is that going to be determined?
Yeah, so temperature and salinity mostly come from the magnetometer measurements. So basically, the Europa has its own magnetic field, but it's an induced magnetic field. And so if it didn't have a subsurface liquid salty layer, it would not be able to have this induced magnetic field in it. And so the strength of that induced magnetic field is dependent on that salinity and that temperature. So there's all kinds of models that show if it's this
I
salinity and this
see.
temperature and this thick of an ocean, the modulations to Jupiter's magnetic field should be like this because of Europa's magnetic field. And if it's less salty or more salty, those modulations to the magnetic field will vary.
Okay, so an induced magnetic field, basically, like if I take a strong bar magnet and I put it next to some magnetic material, that other magnetic material will uh, respond in such a way in its into the atomic level so that it itself has some kind of magnetic field.
Right.
And because Europa is orbiting close to Jupiter, which has a strong magnetic field, and as it's moving around, the magnetic field that it's in is changing. So you'll be able to measure the local magnetic field, you know what Jupiter's is, and put all those measurements together, you're able to figure out like what is that interior really like. And it fortunately happens to depend on things as sensitive as like what's the temperature and salinity of the water inside
Yep.
it.
Yeah,
That's
that's
pretty
exactly
cool.
right.
That's pretty cool. Yeah. So where is Clipper now?
So Clipper just flew by Mars in early March, and now it is on a journey that will take it. It's a little bit past 2 AU now, but it's going to come back around and fly by the Earth and the Moon in December of 2026, and then from there it'll head straight out to Jupiter.
Okay. So in December 2026, it'll be back at Earth
Hmm.
essentially, but moving a hell of a lot faster than it was when it launched
Yep.
in October of 2024. Yeah.
That's
Well,
so
and
fun. We
what's
can all
fun was
wave
that
again.
the Mars flyby was actually to reduce its speed. It wasn't a gravity assist; it was like a gravity slowdown,
Oh,
which
To
was
get it to fall
interesting.
back in to the
yeah.
Earth.
Yep.
Right.
And then
Yeah.
the Earth one will be a gravity assist, and that will slingshot it back out to Jupiter.
I mean, I
Right.
guess it's still a gravity assist, but it's not a. Yeah, that's funny.
Yeah. Yeah.
It's a gravity
I mean, we've
deceleration.
yeah. Well, we've talked before
That's
about
cool.
like missions like the Parker Solar Probe and the Mercury missions, how hard it is to change the energy of an orbit, whether you're, going in towards the inner solar system, um, can be quite difficult and time consuming. So, all right, cool. And I'm sorry, when did you say it gets to Jupiter?
In April of
2030?
2030. Hmm.
April 2030. Okay, so we still got a little bit of time, right?
Yep.
Put
Cool.
it on your calendars, folks.
Yeah. Um, so we talked about this ice layer over Europa's ocean, and there's various degrees of hope and optimism about how habitable.
Habitability.
I was confused because
Liberty
Jim,
Bibberty.
new top quark Jim, says habitable in a way that confuses me.
Habitable.
Oh,
He says
habitable.
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 Yeah.
Bibbity bobbity
Uh,
boo.
our ocean is habitable and inhabited, and so
Correct.
lots of organisms under there,
Correct.
but they depend on sunlight, and that sunlight goes through the water. So there's some new studies
And
about
ice.
how ice on Earth's oceans affects light getting through and what that might do to organisms.
Yeah. So from what I understand, well, from what I do already know, is that light can penetrate through ice at different depths depending on at what wavelength they are, what frequency of light, basically what energy of light. So the UV, for example, ultraviolet gets absorbed at the very, very tippy top of any kind of ice or water or any surface really. But the longer wavelengths, so going into infrared or radio, they can penetrate a lot deeper. But I guess what I didn't know until reading this article is that the like seawater ice, because of its structure, it actually lets light in at all frequencies at the same way. It's got does a lot of different scattering and things, and so all of the light comes in kind of without blocking some wavelengths more than other, at least in the optical portion of the light spectrum. And so
It's smoother. Yeah.
yeah, it's somehow smoother, and that obviously, whatever it is doing, that's the way that microorganisms and organisms in general have evolved on Earth, accepting all of those equal distribution of light coming through the ice. And so, as the sea ice is starting to melt, you're getting different distribution of light that's able to reach deeper and into the oceans. And so, it's affecting how life and photosynthetic organisms basically can exist and how they can continue to thrive.
Yeah,
Yeah.
it was this interesting article that came that, and it's just like it's one of these things that sort of crosses our path because like we get different articles from folks, and I think this one I got out of EOS or something, because it's like we get a lot of sort of like earth science things that tie into planetary science. And I think it's interesting to consider because we talk a lot about different ice coverings and how that might affect habitability and wavelengths of light, but it's actually like super, there's a lot more nuance to it even than I think we usually even talk about of how much and like if it's sea ice versus like clean ice, right? Just pure water ice or whatever, and it creates different like spectral. I think the article said spectral niches with different like species of plankton that are evolved to respond at those wavelengths, right?
Yeah,
And that's
so
pretty
they're going to
crazy.
have to evolve to be more receptive to just one side of the bandpass or the other that actually makes it through,
Yeah.
or die off, which is probably
Well,
more likely.
yeah. I mean, part of this is coming about because on the Earth, a lot of sea ice is melting, and
Yes.
the absorption of the sunlight is quite different depending on whether it's being absorbed by liquid water or ice. And so, as you were saying, the ice, you get
Yes.
a basically gray, like it just reduces all colors, all wavelengths by the same amount. But the liquid water, those molecules are freer to move around in certain ways. So you still have these like certain spectral. And so when there isn't ice, the algae evolve a certain way to like prefer certain spectra. And when there is ice, there's like, I get all colors, so I'm going to eat up all of those different kinds of photons, which I guess is
Yeah.
why they say like ice algae looks brown, because
Okay.
they can absorb all sorts of colors instead of just
Just green.
the non-green or whatever.
Hmm.
Yeah.
So yeah,
Yeah.
interesting.
Yeah. So like different phytoplankton might start being more common, or there might be like a distribution, like things that evolved in sort of Arctic areas that are used to sea ice coverage might have to like evolve, or other ones will start to take their places. I don't know. It'll be interesting.
But,
Yeah.
but correct me
It
if
was
I'm
a
wrong,
really cool
Tracy.
study that like had
Good. Go
I
ahead.
was just saying it had lots of interesting plots of spectra showing like how these different phytoplankton respond, and also like we said, like just the differences in types of ice and how light is transmitted. It was an interesting one. But I think like
Water's
yeah, it really
crazy.
applies to like what we're thinking about for Clipper and a bunch of these other things.
Yeah.
Yeah. Um, Ice for a relative like H2O sounds like a simple molecule. It has all sorts of crazy, complicated
Yeah,
behaviors. Like it forms all sorts of different
I know.
forms
I
of
love when we talk about ice.
solid structures and behaves in really
Yeah.
interesting ways. All right, let me give you your trivia before we move on to our next topic. And the trivia
Okay.
is really just going to check to see how closely you were paying attention to the sponsor message. So, we talked about lava
Oh.
fountains. Okay, so a lava fountain is a very
Yep.
specific thing that's different than an
And
eruption,
chocolate fountains.
which is like which not all eruptions are this way, but frequently think of an eruption as like this explosive belching of the volcano,
Sure.
sort of explosively shooting stuff up into the air. A lava fountain's like you take a hose and you're just like shooting stuff up, right? So that's lava
Yep.
fountain. The question is, which volcano has the highest measured lava fountain, and how high was it? Okay, so that's it. So,
Okay.
obviously not going back for all time, but like that has been observed. What's the biggest, tallest lava fountain that has been seen, and what volcano was that? Okay, bonus
On
points if
Earth.
you get yes.
Oh,
Okay.
that's a good caveat question.
It is because maybe Io might have come into the picture.
Probably.
Jupiter's moon Io, if you hadn't
Exactly.
specified that. Yes. So no, yeah, good point.
Exactly.
Yeah. So, other
That's good
news,
information.
other stories. Um, there
Other
is.
stories.
Oh, we didn't talk about the sun's corona in the space news, Addie.
I know, yeah. That's true. Little space news, a couple of things. There was this cool article that I looked at that for the first time has done adaptive optics imaging on the sun's corona. So the background to this is that like typically, so the sun's corona or the outer layers, they're like crazy hot, crazy energetic, but they're really hard to image because they're much dimmer than the main solar photosphere, the disk. And so typically when we image the corona is like during eclipses when a lot of the the sun is blocked, and you can see all the exciting stuff happening on the outer edges. And with space solar telescopes, we can sometimes see some of that outer stuff, but it's been really hard. And so adaptive optics is a way that we've used for 2 decades now, I think, to like do higher resolution imaging of objects that usually helps reduce like blur in the Earth's atmosphere. So it basically makes the optics adjust so that you can sort of get rid of the blur in the Earth's atmosphere to see things better in a better resolution. But so they're using these techniques to remove blurring from not just the Earth's atmosphere, but from like the dynamics of the solar atmosphere, to be able to actually see like these cool ribbons and braids and fountains and rain, which are also on above the solar disk. And so the images are super awesome, and they discovered some interesting like subscale features they didn't know they had, and some features that were like below the resolution of the telescope even, which is like the best they've been able to get so far. That was like 75 kilometers, which sounds really big and like not great resolution, but like the sun's real big. So
Yeah.
that's actually really good resolution. Um, and it's still, but they still see features smaller than that. So I don't know, it's an interesting thing. And then we'll be able to sort of do some diagnostics and understand some of the energetic processes in the corona better than we've been able to before. And this
Cool.
was with ground-based telescopes.
Well, yeah.
That's impressive.
Adaptive
Yeah,
optics blow my mind. Yeah,
I
how they can
know.
do that. Yeah.
Yeah.
Well,
Yeah.
speaking of hot things, our last story has to do
Hot
with
things. Where's
formation of
Jim?
plant, right,
Hot take.
of planetary cores. So the sort of standard intro astronomy story about like how Earth's core formed, or Earth in general formed. Things are running into each other and they're hitting and they're bringing in lots of kinetic energy, and so they melt on impact, and then they're going to have some amount of radioactive material, which also provides some heating. And you get enough of that stuff, it's warm and melting, and then the dense stuff, namely iron, sinks to the center, and the lighter stuff rises to the top, and you get nice iron core like the Earth has. Um, but there's a question about like planets that are smaller and in colder environments, and how their cores form, because some of them don't seem to indicate that this process happened that way. So I guess these researchers at NASA's Johnson Space Center did some experiments where they found that you could get large scale melting uh, with a different sort of chemistry. So further out, further from the sun, the relative abundance of more volatile elements that you've got in sort of your building blocks to make planets gets bigger. Like in close where Mercury, Venus, and the Earth formed, it was so warm that you have the metals, a lot of metals, and that's easy to explain iron core. But further out, you could have sulfur and oxygen being more abundant. And apparently, sulfur basically acts as it modifies the melting point. So, like the way ammonia does, and we talk about this probably for Europa's ocean, Tracy. They're probably, you said measuring the temperature, and without knowing any better, I would say, well, the temperature is going to be right near freezing, right? It's liquid water, but it's very far out. It's covered with ice. There's no sunlight getting to it, so it'd be very near freezing. But the freezing point of water can be altered by mixing stuff into it, which is why we put salt on icy roads, because it makes it melt at a
Yeah.
different temperature than at a lower temperature than it otherwise would. So that's what sulfur can do in forming planetary bodies in the outer solar system. And so, without it being super hot and then just having liquid metal drain to the center, you can kind of create this gooey, liquid like behavior of these otherwise solids. And they're calling sulfide melts. And these sulfide melts then glom their way down and start forming a core before you would have the other sort of core formation that we're used to taking place. I actually did experiments with these things and saw this
Yeah.
stuff actually happening, which is pretty cool.
Yeah, this
Maybe,
paper was a cool combination of experiments and modeling to try to understand it better. And they did like XCT to look at like how these melts formed, and it was kind of fun.
and maybe I'm hungry, but all I'm picturing is like a s'more with a gooey center,
Right.
being because of the sulfur.
Yeah.
Yes.
Yeah.
Those Ben and
So,
Jerry's core ice cream things.
Mm.
Mm,
Stewie in the center. Earth is still
yeah.
chewy in the
Yeah, I
center.
mean, this is, it is. It's because it's still warm enough. And like, we're discovering more and more that we think other smaller bodies that we thought should have cooled already are still a little bit chewy in the center. So it's
Yeah,
possible
actually,
that there's other things that like sulfur is often one of the responsible things for that, right? So it's like that
yeah.
there's it's that's that like differentiation happens differently if you have these mixes, and also yeah, if you have just like you said, just with ice, you can have inclusions of stuff that make the melting points differ and make heat last longer and all this stuff.
Is Europa chewy in the center, Tracy?
Uh, at the very center, I mean, we think there's a core, like a metallic core.
A solid metallic
Yeah.
core. Okay.
I don't know if it has to be metal, but yeah, like a rocky core
Okay,
of some kind, a higher density core.
Okay.
And we'll know
Solid.
more with gravity
probably
experiments by
solid.
flying the spacecraft, through
Yeah.
it. But we'll see. Even Jupiter's, right? They thought it was going to be more of a
Well
metallic thing,
defined.
and yeah,
And
and
it's
some more
less,
broad,
yeah,
unclear, liquidy goo for a lot
it
of it.
is. Yeah, there's like not this sort of like clear demarcation,
Yeah,
like, oh, now we go from this stuff to this stuff,
yeah.
like we see here on Earth. All right,
Yeah.
let's test how closely you were paying attention to the lava fountain sponsor message. Which volcano had the highest lava fountain and how high was it?
I want to say Kilauea because it's simple to say that.
Okay,
I don't think that's the right answer, but I can't honestly think of another one right off the top of my head right now, even though
that's
you
fine.
probably
How
said it during
high?
the opening
How high
sponsor
would you?
message, and I was definitely listening. 5 kilometers.
Okay, Tracy, what do you think?
I also can't think of a volcano by name other than that one time I hiked Volcan Fuego, which may be a good choice because
Oh,
it
I
means
like it.
fire. It was in Guatemala. I'm gonna guess it's not the right choice because Josh seems
Do
surprised
it.
that that volcano exists. But I
No.
hiked it and it was active while I was there, which was kind of cool with
Yeah.
like lava flows.
Okay,
And
and
we
how
cooked
high?
s'mores on it, so maybe it's all
Nice.
connected. Um,
Yeah.
but I'm gonna go with it was only we'll go 20 feet high.
Wow. Okay.
Oh,
Very
cute.
different answers on the
Hmm.
height. So Addie's going to get it on the height. The volcano is Mount Etna.
Oh,
You've heard
Oh,
of
okay.
that, I'm sure, on
That makes
Sicily.
sense.
And on
I have heard
November
of that one.
23rd, 2013, it had a lava fountain with a sustained height of 2.5 kilometers for 18 minutes. So that's
Wow.
high. That's a mile and a half
That's high.
high. And this is
Yeah.
not, again, explosive. This is like a jet of liquid rock shooting up into the
Yeah.
sky, 1.5 miles, with a brief peak at 3.4 kilometers.
and then
I
does it
remember
So,
you saying something like 3 or 5 kilometers
yeah,
when you were doing the
and
intro, so that
sponsor.
was what I
Yeah.
was thinking.
Good. Good for you.
Awesome.
the does it solidify? Is it still hot on the way down, like, or does it start to solidify in parts? Like, is it like rain
Oh yeah, you'll
rocks on the
definitely
way
get
down?
some like tektites, right?
Yeah,
Yeah. I mean, from that height, the free fall time and going through the atmosphere,
Yeah.
it's gonna solidify. And
Would they
so
be
a
called
lot of
tektites? Probably.
lava samples, you can even really sort of see the crust that forms as it's coming down through the atmosphere. And so, but I was amazed at that height.
Yeah.
You mentioned Kilauea, Addie, was your guess, which is
That's
active
high.
volcano in Hawaii. And I was amazed to see recently that, and this is why I reached out to lava fountains to see if they would sponsor the episode, because there
Sure.
are some lava
Sure.
fountains on Kilauea right now that are hundreds of feet high. And I was like, what? I
Wow.
was amazed that they would go that high.
Yeah.
So yeah, yeah, pretty cool.
Then they told you about Etna and you were like, you have to be a sponsor.
That's like, yeah, I've got to get you guys to sponsor the show.
Yeah.
Well, while it may have felt like being drenched in a lava fountain, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Drusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Pennsylvania, Boston, and Iceland. I'm Tracy
Why
Becker.
not?
I'm
Sorry,
Abby Dove.
I'm stepping on you guys. And I'm Josh Caldwell. We'll get it right one of these days. We're the Astrocork signing off until the next episode of Walkabout the Galaxy. Yay.